What is up, rock stars? Welcome to yet another math video by yours truly. Today we're going to talk about something really cool, something I love to chat about, which is math. And this concept is exponents. You know what? When I think of exponents, I think a lot of things. But I think the biggest thing to think about is a joke. How about this? How did Mary's little lamb get to the moon? You know, Mary had a little lamb. How did she get to the moon? On a rocket sheep. Let's go. Come on, that was funny. Get with it. All right, today's target, what we're going to focus on today is representing patterns and bases using exponents that are whole numbers. Okay, this is kind of an introductory video on exponents. We're not going to go into extreme concepts. We're just going to talk about how do we represent patterns with bases and exponents that are whole numbers. All right, let's start a little bit vocabulary first. When we think about exponents, first of all, let's just look and see what something that has an exponent would look like. All right, so let's take a look at, let's say we had 4 to the third. Okay, we're going to get a little bit more into what each one of these means, but for this vocabulary word, we're talking about base. All right, so we got a whole number right here with 4, and we got this little number here up in the top. Okay, the base is the number that we're going to be raising to a power. Okay, so the base is the 4 in this situation. It's the number that we're going to be raising to a power, and so we want to make sure that we understand when you see that in a question, it says what is the base of this number? The base is the vocab word that means it's the number that's being raised to a power. The exponent is that small little number that I just showed you that's up in the upper right corner. And what it is, it's the, again, I'll write it down here, 4 to the third. The exponent is that 3. Okay, and what it's telling us is it shows how many copies of the base number are multiplied together. Okay, so the exponent, just for your sake of understanding, that's that little guy right there. That's the exponent. We're going to explain a little bit more about what they both do here in a second. Now, exponential form. This is where we're going to talk about those two words combined, because when you take the base and you have an exponent, then you have exponential form. And a way of representing repeated multiplication of the same number by writing the number as a base with its number of repeats. So when you see a number like 4 to the third, let's take a look over here, 4 to the third. Okay, if we're going to write it in exponential form, it means to expand it to repeated multiplication. And what's repeated multiplication? It means the same number multiplied by itself over and over and over, like 7 times 7 times 7 times 7 times 7. I'm repeating the same number and I'm multiplying it each time. Okay, so if we look at the example that we have right there, what you'll see is 4 to the third means you simply take the base and you write it down 3 times. 4, 4, and 4. And then it's multiplied together that many times. 4 times 4 times 4. Pretty simple, huh? This other example right here, the base is actually a variable, which is g, and we're saying g to the 5th. So the base, we write it down 5 times. 1, 2, 3, 4, 5. And then we multiply it, put a multiplication sign in between each one of those. G to the 5th. And I put this vocab word in there just because we want to make sure we're thinking about different ways that people are going to talk about how something's equal or the same. And a lot of times in math, they use the word equivalent. And I want you to just kind of think about what that word means. It just simply means having the same value. For example, we're going to talk about that in fractions. We're going to talk about that in all different kinds of ways. But if I have $1, that's equivalent to 100 cents or 100 pennies. It's the same thing. Okay? They look different, but they're equivalent in value. If I have 120 seconds, I've gone 2 minutes. So I could tell you I ran for 120 seconds, and then you could tell me, oh, you know what? I ran for 2 minutes. Sounds like a whole different ballgame, but they're actually the same thing, so they are equivalent. Okay, let's look at this. So based on what I just told you, write the expression using an exponent. Okay, so now we're going to work backwards. Remember I told you repeated multiplication. When we're thinking about exponents, we're thinking about repeated multiplication. Well, in case you don't know by now, and most of you should, but in case you don't know, when you see a dot in between numbers in math, that is the same thing as multiplication. So if you see 4.3 and it's up high like that, that means multiplication. Now, if I see 4.3, that's a decimal. Don't get those confused. So when we're looking up at those 7s up there, we're seeing 7 times 7 times 7 times 7. So we have the same number multiplied 4 times. All right, so what does that mean? Well, let's write down our base. 7. Base is 7. That's the number we're multiplying. And what does it look like as an exponent? To the 4th. Pretty simple, right? And what does that equal? 7 times 7 times 7 times 7. That's pretty bad drawing right there. That should be right about there. But anyways, you know what I mean. Okay, let's try another one. How about you try this one on your own, and then we'll walk through it. Okay, what's the base? Well, it's the same number multiplied by itself over and over and over again. That would be the base is 10. How many times is it multiplied together? 1, 2, 3, 4, 5, 6, 7. 10 to the 7th. Pretty cool, huh? Told you it wasn't that hard. All right, so now let's try to solve what they actually equal. So when we're talking about, that last one was 10 to the 7th, and here we're looking at 10 to the 6th. So let's talk about what this might equal, okay? So if we're saying something, let's look at these bases right here. So if we have 10 to the 1st, that just simply means 10, write it down, and there's no multiplication, so it's just 10. All right, if we look at the next one, we see that we have 10 to the 2nd, which is 10 times 10, right? We have the 10, we write it down 2 times. What is 10 times 10? Well, it equals 100. 10 to the 3rd would be 3 tens, and that equals 1,000. Okay, and 10 to the 4th, you guessed it, would be 4 tens, and that equals 10,000. So remember at the beginning I told you we're looking at patterns? Look at those answers when we're dealing with base 10 and see if you can see a pattern developing in those numbers. Okay, so if you guessed when you were looking at these that you saw a pattern, you said 10 to the 1 equals 10. Well, that 1 gave us 1 0. 10 to the 2nd equals 100. Guess what? There's 2 zeros. 10 to the 3rd equals 1,000. Guess what? There's 3 zeros. So you're noticing a pattern. So if we go back to the question, what do we think 10 to the 6th will equal? Well, it'll be a 1 with 6 zeros. So your answer would be 1 million. Not too shabby, huh? Well, now we don't have the zeros, so the pattern's a little bit different. But same thing, 4 to the 1st, that's just 1 4. 4 to the 2nd, that's 4 times 4 equals 16. 4 to the 3rd is 4 times 4 times 4 equals 64. Now, how did they get to that? Well, we already know that 4 times 4 equals 16, so if we take those, we have 16. And then if we multiply it by 4 again, 16 times 4, well, if you're allowed to use a calculator, you could use a calculator. If not, you simply do your multiplication. What's 16 times 4? Well, 6 times 4 is 24. 4 times 1 is 4 plus 2 is 64. So that's how they came up with that answer. So let's use what we know to keep going, okay? So we already know all that. Let me clear these off and start from 4 to the 4th. If we get to 4 to the 4th, we can get to 4 to the 5th, all right? Which means we take that 64. Remember we just multiplied by 1 more 4? So, because we know 4 times 4 times 4, which is 4 to the 3rd, equals 64. So we already have 64, and now we're just going to multiply it by 4 one more time. Okay, and that's going to give us 64 times 4 is 4 times 4 is 16. 4 times 6 is 24 plus 1 is 25. So now we got 256. Okay, so if we know 4 to the 4th is 256, we can probably pretty already guess what the answer is because there's only one number that's bigger, but let's go ahead and do it. If 4 to the 4th was 256, well, let's erase that and do that again. If we know 4 to the 4th equals 256, and then we come up here and say, what is 256 times one more 4? Because that would give us 4 times 4 times 4 times 4 times 4. And we multiply that together. You guessed it. 4 times 5 is 20. 20 plus 2 is 22. 4 times 2 is 8. 8 plus 2 is 10. And so D is our answer. Okay? So you can see exponentially, when something's getting bigger, it gets bigger at a rapid pace. So we got 4 times 4 is 16. Then we get 4 times bigger, we get 24. Then we get 4 times bigger than 64 is 256. And then 4 times bigger than 256 is 1024. So let's base that we've just learned, and let's see if we can figure out which of these are equivalent to 6 to the 4th. Okay, so I'm going to go down here. I'm going to try to write with a highlighter, see if this looks a little better for us. And let's just simply write down 6 to the 4th. And let's break it down into exponential form. So if I have 6 to the 4th, well, let's change colors. 6 to the 4th. And we know that we write the base down 4 times. Okay, so that's what it means broken down. Well, already I can see I have found one of the boxes that works. So remember, the question is, which of the boxes below are equivalent or have the same value as 6 to the 4th? Well, 6 to the 4th equals 6 times 6 times 6 times 6. So we know, right off the bat, we know that this one works. Okay? Now let's go back to solving now. What is 6 times 6 times 6 times 6? Well, you can write these down any way you want to. You can say, well, what's 6 times 6? That's 36. And then we're going to multiply 6 times 36 again. I'm sorry, 36 times 6, so we can get this next 6. And I'm going to go up here and I'm going to multiply 36 times 6. 36 times 6 is, 6 times 6 is 36. 3 times 6 is 18, plus the 3 is 21. So we know that 216, we've got 3 of them now. So basically what we're saying is 6 to the 3rd equals 216. Now we got to multiply that times 6 one more times. Okay, and I'm not going to write it on here, but I'll go ahead and tell you 216 times 6 is equal to 1,296. Okay, so we know that one works. All right, we know that one works, which is exactly what we're trying to accomplish, is figuring out how many of these work. Okay, now before we move on, let's check out a couple other things. In this sequence of things that I did down at the bottom, in other words, in this area right here, let's see if we notice anything else that can help us from up above. Well, look at this. 6 to the 3rd was 216, and then we multiplied it times 6. 216 times 6. If I look up there, I see that answer right there. That works. Okay? If we look at this and we say, I'm gonna erase this and then circle a couple things real quick. We already know that that's true. We already know that that's true. We already know that that's true. Okay? So then I'm going to go back up to this one up top here and say, what did we say 6 times 6 is? Okay, we said that 6 times 6 was 36, which means 6 times 6 is 36. And we haven't multiplied those together yet. Well, where do we see that? That's right. You see it right below here. And if we know that 6 times 6 times 6 times 6 is the same thing as 6 to the 4th, right? 6 times 6 times 6 times 6 times 6 times 6 is not true. So we definitely know that's not true, because that would be 6 to the 6th, right? So let's go ahead and mark that guy off. He doesn't work. This one right here is trying to convince people to make the most common mistake in exponents, which is when people say 6 times 4. That is not the way exponents work. Okay? And then 6 times 4 equals 24, which is where they're trying to trick you. So 24 does not work. And lastly, exponents flipped over do not equal the same value. Okay? So that would be 4 times 4 times 4 times 4 times 4 times 4. And that's going to give you a number really big. I think it's around 4,000 and something. So that one does not work either. So your answer were just those 4. You have to break down each one of them. You have to look for patterns. You have to look for ways exponents work to get you to where you're trying to be. Hope that's helpful for you. It's going to be useful in any work going forward, because you're going to use exponents a lot in your work. All right, so let's wrap it up here just by remembering an exponent is a number which is called a base. Okay? And we take that base and we give it an exponent, which is a little number up top. And all that tells us is to take that number, the base, and multiply it by itself as many times as the exponent tells us. 7 times 7 times 7 is 7 to the 3rd. All right, I hope that was helpful. Keep on rocking and come back and see me next time you want to hang out and be a math rock star. Let's go! Thanks for watching, y'all. Have a great day.